Hello. In this video, I will go over some dilution types of problems. So this is under concentration, reconstitution, and dilution, and we are going to do some dilution problems. So dilution is when you add more liquids. Let's start with example one. So example one, we have an order of gentamicin, gentamicin, 200 milligrams IV 98H using a vial with a concentration of 800 milligrams per 20 milliliters. Dilute the ordered dose with 50 milliliters of normal saline and administer over 2 hours. Round all answers to the nearest tens. Okay, so on this one, we can do it, I believe we could do it three ways. We could still do it with dimensional analysis, ratio and proportion, and we can do it in formula. So what are they asking? Dilute the ordered dose with 50 milliliters with a normal saline and administer over 2 hours. So I believe your final answer still should be in milliliters. Yes. So our final answer still should be in milliliters. And let's see. So if you want to read it, I'll read it again. Order of gentamicin 200 milligrams IV 98H using a vial with a concentration of 800 milligrams per 20 milliliters. Dilute the ordered dose with 50 milliliters of normal saline and administer over 2 hours. Round all answers to the nearest tenth. So yes, our final answer shall be in milliliters. Let's start with, oh, there's part A, sorry. So part A says how many milliliters will you remove from the vial to dilute with 50 milliliters of NS? So how much do we take out of the vial before the dilution? So yes, we still on part A we can do it three methods: dimensional, racial proportion, and formula method. So let's start with dimensional analysis. So yeah, they're asking you how many milliliters, so our final answer shall be in milliliters. So let's start with dimensional analysis. So with dimensional analysis, you always start with what you're given. So we were given 200, hold on. Okay, so we were given 200 milligrams times, and then we want to somehow get into final answer has to be in milliliters. So I guess I have to put milligrams on the bottom because I want to get rid of the milligrams. And I believe we have to put milliliters on top because our final answer has to be in milliliters. So what is the relationship between milliliters and milligrams based on the problem they gave us? They specifically said, um, with a vial concentration of 800 milligrams per 20 milliliters. So if you go up to the problem, it says we were using a vial with a concentration of 800 milligrams. So you put 800 under here per 20 milliliters, and you put 20 milliliters on top, right? You do not put 20 on the bottom and 800 on the top because there's no way you're going to get rid of the milligram mg, right? And then this has a 1. And as you can see, the milligrams disappears and the milliliters is our final unit. That's good. So go ahead and multiply across because that we are multiplying fractions. So multiply 200 by 20. And then it's going to be 1 times 800. Okay. And then what's 200 times 20? That is 4,000. And then 1 times 800 is 800 milliliters. And we are given 5 milliliters. So what that 5 milliliters really means is, so 5 milliliters, it's what you're going to take out of the vial before the dilution, right? So 5 milliliters. is what? Okay, so let's do the same problem using ratio and proportion. So yeah, okay, fraction here, fraction there, and let's see. We were given so 20 we were given 20 milliliters, 800 milligrams per 20 milliliters. So you could put milliliters on the top and milligrams on the bottom, right? Or you could put milligrams on the top and milliliters on the bottom. It doesn't matter as long as this is the same here, and then this is the same with here, right? So we were given for 800 milligrams, there were 20 milliliters, and uh, we, we want to know how many milliliters for 200 milligrams. Okay, cross multiply, so this is going to be 800x equals to 20 times 200. 20 times 200 is 4,000. And then divide this by 800. And you get x equals 5 milliliters. Okay. And then the last method I'm going to use is I can use the formula method. So if you recall, formula is desire for have times vehicle. Okay. Our desire was 200 milligrams, right? We want to know how many, yeah. And we had 800 milligrams, and the units are the same, so that's good. If they're not, then you have to convert it or it doesn't work. And then our vehicle was 20 milliliters. And when you put it all together, you get 5 milliliters. I know the direction says round your answers to your tens, but you don't include uh trailings. You don't include you don't say 5.0, right? You don't add this extra zero. I believe that's trailing zeros, right? We don't really include that. But we do include leading zeros, leading zeros. Okay. Okay, there's a part B says how many total milliliters will be administered over 2 hours. So if we're administrating every 2 hours, um, so in part A was how many milliliters will you remove from the vial? We said it was 5 milliliters. So it's going to be how many total milliliters will be administered. So you're going to need a 5 milliliters plus 50 milliliters, right? Because it says it will dilute, yeah, dilute with 50 milliliters. So yeah, we're gonna add 5 milliliters by 50 milliliters. So your total, how many total milliliters will be administered? It would be 55 milliliters total. Okay, let's move on to C. So he says, what is the concentration of the final solution? Final answer should be in milligrams per milliliter. So it's basically 200 milliliters because we have an order of 200 milligrams IV, so it's going to be 200 milligrams over the answer from part B. The total milliliters will be administered is 55 milliliters. So that's true because our final answer is in milligrams per milliliters, and 200 divided by 55 is 3.63636. Now, we do have to round it to the nearest tenths, so 6 is the tenths, and then you look at the neighbor, which is 3, and 3 is not 5 or beyond, so you don't round. So it's just going to be 3.6 milligrams per milliliter. You can also, so this is, you can write it as slanted or you can write it as completely horizontal, like that. Okay, let's move on to example 2. Oops. Okay, so example 2 says we have ranitidine. I can't say the word correctly because I don't know how, I'm not a nurse. Um, I'll say really careful. Ranitidine of 50 milligrams, 50 mg IV every 6 hours using a vial with a concentration of 1,000 milligrams per 40 milliliters. Dilute dose of 0.9% NaCl to achieve a concentration of 2.5 milligrams per milliliters. Inject at 4 milliliters per minute. Round your answers, all answers to the nearest tenths. So let me read it again. Ranitidine, 50 milligrams IV every 6 hours using a vial with a concentration of 1,000 milligrams per 40 milliliters. Dilute dose in 0.9% NaCl to achieve a concentration of 2.5 milligrams per milliliter. Inject at 4 milliliters per minute. Round all answers to the nearest tenths. So the first part of the question says, how many milliliters of ranitidine will be diluted with 0.9% NaCl? This is before dilution. So how many milliliters of ranitidine will be diluted with a 0.9% NaCl? So I believe we could do the 3 methods. We can do dimensional, ratio, and proportion and formulas. So our final answer has to be in milliliters. So let's start with dimensional analysis. So with dimensional, you always start with what you have. We we had ranitidine of 50 milligrams, so 50 mg, 50 milligrams times, and then I have to get our final, how many milliliters do we have to get rid of the milligrams and put milliliters on the top. So what is the relationship between milliliters and milligram? Well, it was based on the problem, we had a concentration of 1,000 milligrams for 40 milliliters. So you're going to put 1,000 on the bottom, 1,000 milligrams, and 40 milliliters. Well, so I just want to make sure one, this is what we were given, 1,000 milligrams per 40 milliliters. Why didn't we put it like this? Why isn't this wrong? No, it's not. You can flip it. You can flip it. You could put 40 milliliters on the top and 1,000 milligrams on the bottom. It's not changing your problem, right? So the reason why I put 1,000 milligrams on the bottom is because I want to get rid of the milligrams, right? And the reason why I put milliliters on the top is because I want that as my final answer, my final unit. Okay. And then this has an invisible one. And then as you can recall, you can multiply fractions, so multiply across. So you could do 50 times 40 and then it's 1 times 1,000. And let's see, on the top, what's 50 times 40? It is 2,000. And then on the bottom, what's 1 times 1,000? 1,000. And when you put it all together, you get 2 milliliters. And it says round to the nearest tenths, but you recall we don't include this extra zero. Those are trailing zeros. We don't include that. So this is my final answer. Okay, let's do the same problem doing ratio and proportion. So fraction here, fraction there. And we want milliliters and we also have milligrams. So you can put milliliters on the top and milligrams on the bottom, or vice versa, mg on the top and milliliters on the bottom. It doesn't matter as long as this is the same as the top and then this is the same as the bottom, right? So we were given 1,000 milligrams or 40 milliliters, and we want to know how many milliliters are in 50 milligrams, right? And then go ahead and cross multiply. So 1,000 times x is 1,000x. And then it's 40 times 50. And then 40 times 50 is 2,000. And then this is 1,000, x equals 1,000 divided by 1,000. The zeros cancels and you're left with 2 milliliters. And then for the formula method, it's going to be desire over half times vehicle. So our desire was 50 mg, and then our half was 1,000, and then our vehicle was 40 milliliters. Okay. That gives you 2 milliliters. Okay, let's do part B. It says, what is the total volume? What is the total volume needed to achieve 2.5 milligrams per milliliters concentration? And formula method cannot work because I believe in the formula, both units has to be the same. They're not. So what is the total volume? So they're asking, a volume is most likely going to be milliliters in our case, right? So let's start with dimensional analysis. Okay, dimensional analysis. We were given 50 milligrams times, and then they're asking you what is the total volume needed to achieve a 2.5 milligrams per milliliter. So that's what we're going to use. We were given, in part B, we were given a 2.5 milligrams per milliliters. So can I leave it like this? Should I put it exactly like this? No, this is a 1, by the way. I got to get rid of the milligram, so I can flip this, so I can say 1 milliliter or 2.5 milligrams, right? This is not wrong. Yeah, this is not wrong. So that's what I'm going to do. The reason why I have to do it like this, why I have to flip it, is because I want to get rid of the milligrams and I want my final answer to be milliliters, right? So for 1 milliliters, there's 2.5 milligrams. And then as you can see, the milligrams disappears, and then you're left with 50 times 1 over 1 times 2.5. And then you're going to get 20 milliliters, and there's it. Okay, let's do the last part C. So, oh, wait, we can do this using ratio proportion. Okay, so ratio proportion would be fraction here, fraction there. And then we were given milliliters and milligrams. So I could put milliliters here, milligrams on the bottom. And we know that for 1 milliliter, we were given for 1 milliliters, there was 2.5 milligrams. We want to know what was the total volume? So my volume is milliliters, so that's my unknown. Um, for 50 milligrams. Okay, go ahead and cross multiply. This is going to be 2.5x equals to 1 times 50. 1 times 50 is 50 equals to 2.5x. Divide this by 2.5. And you get 50 divided by 2.5 is still 20. Okay. Okay, last part of the question says how many how many diluent should be added to achieve the concentration? So when they say diluent, they really mean milliliters. So my dose is 2 milliliters. I need a final volume of 20 milliliters. So I only need to add 18, right? So let me write this down. Um, my dose from part A, it was 2 milliliters. So my dose is 2 milliliters. I need a final dose or a final volume of 20 milliliters, right? That's 20 milliliters is from the answer from part B. So 20 milliliters from part B, and then 2 milliliters was from the answer part A. So how much you went from 2 to 20? That means you need to add. So I only need 18 milliliters. Okay, that's my answer. Okay, I will stop here.